In mathematics, two quantities are in the golden ratio if the ratio is the same as the ratio of their sum to the larger of the two quantities. So, expressed algebraically, that b is bigger than 0, but b is smaller than a. The Greek letter phi denotes the golden ratio. The constant phi satisfies the quadratic equation phi squared equals phi plus 1. It is an irrational number with an estimated value of 1.61.
Although it is not known by whom it was first discovered, it is seen that the Egyptians and Greeks had some studies on this subject. Euclid, in his thesis titled Elements, written in 1300 BC, expressed the golden ratio as extreme and significant division.
The golden ratio was also called the amount of phi, the first two letters of its name because of his discovery of the wonderfully arranged 1-to-1 overlapping discoveries in universe.
In our daily life, we constantly encounter mathematics and geometry. The Fibonacci sequence is a series of numbers 0, 1, 1, 2, 3, 5, 8, 13, and 21. The first three numbers can be defined when we make squares with those waves. We get a nice spiral called the Fibonacci spiral. But when we take any two successive Fibonacci numbers, the ratio is very close to the golden ratio phi. This ratio was named the golden ratio by the Greeks.
Leonardo Fibonacci of Italian origin, the most famous mathematician of the Middle Ages, discovered the claim that he was after a sequential relationship and a monstrous lattice between each other, or according to another way. He came out of the Indo-Arabic civilization and carried it to Europe.
The golden ratio, which is known to be used in Egyptian pyramid of Cheops, in the paintings present by Leonardo da Vinci in his work, called divine ratio, is also known as Fibonacci numbers.
The golden ratio. The golden ratio was likely first discovered by mathematicians of ancient Greece, including famous names like Pythagoras and Euclid, but was later studied by folks like Leonardo Banacci, who made it more popular. And a picture of Leonardo Banacci. The Fibonacci sequence, described by Leonardo Banacci, that defies spirals evident in flowers, galaxy spirals, and hurricanes, all use the golden ratio. And you can find all of the patterns of the golden ratio in the nature. And because of its simplicity and complexity at the same time, many artists, architects, and musicians consider the golden ratio to elevate their work when creating, and the ratio is said to be evident in Parthian Temple and The Last Supper, among many other famous works. The Last Supper and the Parthian Temple. Thank you for your time.
Golden ratio in real life. Where can we find the golden ratio in real life? We can find it on the face of human and non-human. For example, the mouth and nose are positioned at the golden section of the distance between the eyes and the bottom of the chin. We can see the harmony of the face of Kate Moss on this picture. We can see the golden ratio makes a beautiful face.
There is a particular proportion between large and small, and when this proportion is right, it just looks beautiful. This special proportion, the relation between one length and another, is called the golden ratio, or phi, and it can be found in a multitude of places. The golden ratio is 1.618, represented by the Greek letter phi, is said to be a mathematical connection between two aspects of an object. This golden ratio has a strange mathematical property. When you divide the number 1 by this quantity, then it's equal to 1 plus the same number. So, 1 divided by 0.618 is equal to 1.618. Golden ratio can also be found hidden inside a simple sequence of numbers that was discovered in the 13th century by a man named Leonardo Fibonacci. The Fibonacci sequence starts like this: 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and continues on forever. Each number is the sum of the two numbers before it. It's a simple pattern, and perhaps not that impressive on its own. That is until you realize that this ratio is the key to everything from the number of spirals on a sunflower head, our own limbs, encrypting computer data, and why the Mona Lisa is so pleasing to the eye. It appears to be a kind of built-in numbering system to the cosmos. Our body is designed on a 1 to 1.6 ratio. If you look at the distance between your shoulder and your elbow, and then from your elbow to your fingertips, from your shoulders to your elbow is 1, and then from your elbow to your fingertips is 1.6. But it doesn't stop there. Now take that further. The distance from your fingertips to your wrist is 1, and from your wrist to your elbow is 1.6. Keep it going. From the furthest tip of your finger to the bottom of your fingers is 1, and from the bottom of your fingers to your wrist is 1.6. Now check out the spacing over your knuckles, 1 to 1.6. From your head to your belly button, that is 1, and from your belly button to your feet is 1.6. From your toes to your knees, and from your knees to your hips, golden ratio applies again. Ever wonder why your two front teeth are so much bigger? Answer: golden ratio. Scientists have discovered that the golden ratio pattern is necessary for the human brain, the neural system, our sense organs, and our lung system. The golden ratio sequences is even in the helix of our DNA, and it forms the very rhythm of our heartbeat pattern. This golden ratio is the mathematical sequence in the spirals of our storms, tornadoes, hurricanes. These all spin in this golden sequence of 1 to 1.6. Even the waves can be measured using this ratio.
Golden ratio is also known as golden section, medial section, golden proportion, or divine section. Many forms of nature feature the golden ratio in some arrangement, from human facial features to the petals on flowers. Many artists and architects, also musicians, consider the golden ratio when creating their work, and the ratio is said to be evident in Pantheon Temple and the Last Supper painting, among others. The Fibonacci sequence, described by Leonardo Banacci, the defined spirals evident in flowers, galaxy spirals, and hurricanes, used the golden ratio.
Hello, I'm Irina Iskula Katushan. I'm in 8th grade and German high school in English. I'm going to solve a problem with the golden ratio in a pyramid. The VABCD is a regular quadrilateral pyramid whose side bases are golden triangles. The edge of the base is 5 centimeters. At point A, we have to find the lateral edge. To do this, we need to unfold the pyramid, as it's shown here. And these are the following calculations we have to do. At point B, we have to check that the ratio between the lateral edge and the edge of the base is phi. And this is how I solved it. And we can see as a result the golden number. In the end, I would like you to find the answer to point C, which says to calculate the lateral area of the pyramid.
It's about Egyptian pyramids and tombs that were built using the golden ratio. The Ahem Papyrus of Egypt provides details of the construction of the Great Pyramid at Giza in 4700 before God, with proportions according to sacred ratio. Much has been written about the secret of a pyramid, noting that the axis of the corridor is centered on the pole star of a respective era with great accuracy. 4 minutes of the angle made in relation to the alpha star of Dragon, representing the geographical north, and the 4 angles of the base are directed to north, east, south, and west, with the same correctness. The height of the pyramid multiplied by 1 billion represents the Earth-Sun distance. The perimeter of the base divided by the height gives 2p, the double of 314, which could only be verified after 1617 by Leibniz.
Fibonacci was a famous mathematician. He introduced the Hindu-Arabic number system into Europe and had a huge impact on arithmetic, algebra, and number theory. He is one of the greatest mathematicians of the Middle Age in Europe. His real name was Leonardo Pisano Bogolo, and he lived between 1170 and 1250 in Italy.
Rectangles can be created via the golden ratio, known as golden rectangles, that have sides of a 1 to 1.618 ratio, and they are widely accepted as being more aesthetically pleasing than rectangles of random sizes. And the golden ratio is also known as the divine proportion because of its perceived beauty.
Flowers, the number of petals is a Fibonacci number. On many plants, the number of petals is a Fibonacci number. Buttercups have 5 petals, lilies and iris have 3 petals, and delphiniums have 8. Corn marigolds have 13 petals, some asters have 21. Bohemia's daisies can be found with 34, 55, or even 89 petals.
In mathematics, two quantities are in the golden ratio. If their ratio is the same as the ratio of their sum to the larger of the two quantities expressed algebraically for quantities a and b with a bigger than b and b bigger than 0, a plus b on a equals a on b and equals pi, where the Greek letter pi denotes the golden ratio. The constant pi satisfies the quadratic equation pi to the power of 2 equals pi plus 1 and is an irrational number with a value of pi equals 1 plus square of 5 on 2 and equals 1.6180.
Squares is also used in music. Johann Amadeus Mozart is famous for his music. Also Mozart is used the Fibonacci sequence of his well-known piece of work music. A good example is the Mozart Sonata 279. In fact, he wrote the mathematical equations in the margins and sheet music. Sequence is also used in music. Johann Amadeus Mozart is famous for his music. Also Mozart is used the Fibonacci sequence of his well-known piece of work music. A good example is the Mozart Sonata 279. In fact, he wrote the mathematical equations in the margins and sheet music. Sequence is also used in music. Johann Amadeus Mozart is famous for his music. Also Mozart is used the Fibonacci sequence of his well-known piece of work music.
The myth that Leonardo da Vinci believed the golden ratio was the ratio of the height to the width of a perfect human face, and that he used the golden ratio to create the Vitruvian Man, although there is no evidence against this idea, or there is no evidence in its favor or its either, though the only reason to believe in this idea is faith itself. The same is true in the case of Botticelli and his famous painting, The Birth of Venus, or in the case of George Seurat and his painting Circus Parade. There are also painters who intentionally use the golden ratio, but they apparently used PA only as an experimental technique and not as an intrinsic aesthetic motive. The Cubists organized in Paris in 1912 an exhibition called Section d'Or, but the name had no connection with the exhibited art.
The golden ratio, which is sometimes called golden section, extreme and mean ratio, golden mean, or divine proportion, is denoted by the letter phi after the name of Phidias. The Greek sculpture painter and architect is approximately as above.
Ratio is the ratio of a line segment cut into two pieces as follows.
The golden ratio was called the extreme and mean ratio by Elucid and the divine proportion by Luca Pacioli. Mathematicians have studied the golden ratio's properties since antiquity. This is the ratio of a regular pentagon's diagonals to its sides, and thus appears in the construction of the dodecahedron and isochedron. A golden rectangle, that is a rectangle with an aspect ratio, may be cut into a square or a smaller rectangle with the same aspect ratio. The golden ratio has been used to analyze the proportions of natural objects, and the artificial systems such as finance markets, in some cases based on dubious fits to data. The golden ratio appears in some patterns in nature, including the spiral arrangement of leaves or the other parts in vegetation.
This sequence is also used in music. Johann Amadeus Mozart is famous for his music. Also, Mozart used the Fibonacci sequence of his well-known piece of work music. A good example is the Mozart Sonata 279. In fact, he wrote the mathematical equations in the margins in sheet music.